Good morning, everyone. Thanks for joining us. Good morning. Welcome to the session, Powering the EU Through to 2050, Turning the Bioeconomy into Reality. My name is Liz Corbin. I am the Research Director of Metabolic and the Director of Metabolic Institute, and I will be hosting today's session. I will be joined by three amazing panelists, Carlos Lopez, Juan Perez, and Harman Decker, which we will have a panel after a brief introductory presentation by myself on the opportunities, barriers, and overall potential of bioenergy in succeeding upon the EU's energy transition goals. So first, we'll start with a brief presentation in terms of background context, and then we'll move straight into the panel. Great. First, next slide, please. So based on the OECD's Global Material Resource Outlook, currently we are consuming up to 24 million K-tons of biomass per year, and that accounts for about 26% of natural resource extraction annually. Next slide. And biomass is a really critical part of the bioenergy story, and also the overall EU Green Deal narrative. That's because across the 20th century, fossil fuels have really provided an unprecedented source of energy and raw materials for our economy and our way of life. Yet, we all know we are starting to run on empty. For every 4 barrels of oil that we consume, we only discover one more. And in an effort to transition towards a green and renewable economy, today we're seeing a large shift towards bio-based production systems as an alternative to fossil fuels, and this is often called the bioeconomy, where agricultural, forestry, and aquatic resources are being used in replacement of resources like fossil fuels to produce the chemicals, materials, and energy that we need as a society. Next slide. By analyzing global data sets, including the FAO, we can see that today biomass remains a critical resource within our global agri-food, construction, manufacturing, energy, and textile sectors. And with demand for biomass rising across all of these sectors, it's really critical that we begin to discuss how best to balance this important resource and allocate this resource across the various needs of local communities in a way that's environmentally sustainable. Next slide. So in collaboration with a group of global partners, Metabolic Institute has been developing a new open data initiative called the Global Metabolism Initiative, which will launch early next year. And what the GMI does is it combines spatial data on global material stocks and flows with cross-sectoral deep dives into key value chains where we map context-specific environmental and social impacts, and we really look at cross-sectoral competing demand. And in this way, it's our ambition that the GMI can offer a global overview of how we're currently consuming key natural resources like biomass, what the cross-sectoral competing demand challenges are that arise from that, and provide spatial insight into where social and environmental impacts are being felt the most. Next slide. All GMI data is completely open and will be made accessible through a web-based platform, which will launch in January of next year. And what we're aiming to do is really show spatially the impacts of resource cultivation and extraction across a range of environmental, social, and climate indicators. Now, next slide. To the topic at hand, zooming into energy for today's session, the energy sector is responsible for almost 3/4 of emissions that have already pushed global average temperatures 1.1 degrees Celsius higher since pre-industrial use. This is making the energy sector a critical pillar in finding solutions for climate change. As part of the European Green Deal, the Commission has proposed in September of 2020 to raise the 2030 greenhouse gas emission reduction target, including emissions and removals, to at least 55% compared to 1990 levels. This increased ambition, alongside energy efficiency and renewable energy targets, is really set to enable the EU to move towards a climate neutral economy and implement its commitments under the Paris Agreement. Today, the greenhouse gas target has been implemented and is being implemented by the EU emissions trading system, the effort sharing regulation with member states' emissions reduction targets, and land use change and forestry regulation. And through this kind of cross-departmental, multi-pronged approach, where all sectors are being expected to contribute both to reducing emissions and increasing removals, this is how the EU is aiming to achieve these ambitious targets. Next slide. This morning, we'll be looking at two models to help us understand a little bit more about the possible demand and supply scenarios for what role biomass can play in the green energy transition and satiating the energy demand here in Europe. The two models that I'll be presenting, and we can discuss more in depth in the panel, is first the impact assessment of the climate target plan, which is published by the Commission in 2020. And it provides data for the demand of biomass for different 2030 and 2050 scenarios. In addition to that, we'll be looking at the JRC's Espresso dataset published in 2019, which provides biomass supply scenarios based on an EU 28-wide open dataset for energy models on renewable energy potential. What these scenarios show is that towards 2050, biomass demand for bioenergy will be increasing substantially. However, the type of biomass used is highly likely to change, giving an increasingly limited supply of the biomass streams that we're currently using for bioenergy. Next slide. Conventional biofuels are likely to be phased out due to an increase in advanced biofuels for energy crops and agricultural residues. Also, an increase in the use of waste is being projected as a result of improved industrial and municipal waste collection. And moreover, new biomass categories, for example, lignocellulosic grass, like switchgrass, and short rotation coppices, like poplar and willow, are really seen to play a bigger and bigger role in biomass going into energy. Looking at the Espresso scenarios, they indicate that there is enough supply potential to meet 2030 demand, with a slight exception of waste. However, as we come up to 2050, demand within these scenarios is exceeding supply in both the low and medium scenario. And in the high scenario, whilst there is sufficient supply of biomass to meet total demand, there are some small shortages projected in energy crops as well as waste. And I'm really looking forward to diving into the comprehensiveness of these models and how our different panelists also see supply and demand scenarios for Europe in their own work. Interestingly, the large majority, so over 93% of the bioenergy used within both the JRC and Commission scenarios is expected to be produced domestically here within Europe for both 2030 and 2050 scenarios. Next slide. It is also important to place the promise of bioenergy and the possible role that biomass can play within this broader context of climate change and environmental sustainability for Europe. It's also important to note that 3/4 of the world's land area capable of supporting vegetation is actually already being managed and harvested to meet human food and fiber needs. And much of the rest of this land actually contains the world's remaining natural ecosystems, which very much need to be conserved and restored in order to store carbon and combat climate change. So, with projected demand for meat, dairy, commercial timber, and pulp remaining very high, alongside this growing demand for bioenergy, one of the questions we'll look into today is it possible to balance competing demands for biomass and ensure that bioenergy feedstocks don't undercut our European and global efforts to combat climate change and achieve a sustainable food future? There are most certainly some sources of additional biomass that are not competing with food production or otherwise dedicated use of land. You'll find some of these listed to the left-hand side of this slide, and they include things like timber processing waste, sawdust, black liquor, unused manure, urban food waste, and municipal organic waste. But one of our challenges will be to see how these possible resources really can be used at scale. At what scale? Since most of these residues are already being used for things like animal feed or soil fertility. Without a doubt, one or more of these sources will most certainly be a critical part of a very local energy transition in local context here in Europe. But what is unknown is what size and scale we can achieve with some of these underutilized sources across Europe. And last slide, please. So in today's panel, we will be diving into that. We'll be hearing from sectoral experts, Carlos, Juan, and Harman, and really be exploring the current status of the bioenergy transition, unpacking some of the potentials and barriers, and looking at how this sector can grow and continue to evolve in a way that's truly sustainable. Thanks, and we can move into the panel. Well, hello, welcome everyone. Thanks so much for joining us. Do we also have Juan on the screen? I think I see myself double. Great. Okay. Hi, everyone. Now I see myself double, but also Juan, so that's okay and quite good. Let's start things off first with a question for you all. We know we need a green energy sector to fuel Europe. The EU, as we've heard, has set really ambitious targets for energy transition, with even higher targets due to come in relatively soon. Yet, many would say, and a lot of research has said, that progress really isn't being made fast enough, given the very short time frame we have left to make impact. So I'm really curious to understand what role you all feel biomass can realistically play within this green energy transition. What types of biomass should we be prioritizing and really investing in? At what scale do you feel they can operate? And how does it relate to the broader EU energy transition goals, including efficiency and renewables? I'd love to get a 1-minute introductory response from each one of you. Maybe we can start with Harman.
Thank you, Liz, and thanks for the great presentation as well. Biomass is often not being looked upon very favorably due to some bad practices in the past. But biomass is actually really playing a crucial role within the energy transition. And I think we need to realize that if we would like to move fast, and we all want to move fast, that biomass is very quickly and very fast available for us all. So yeah, that's, I think, my opening statement. It is very, very important to start now.
Thanks so much, Harman. Carlos, would you like to have an opening statement?
Good morning to everyone. First, I would like to say apologize because I have to wear this mask because I'm starting the office. Well, I agree with Harman that this biomass is crucial for any transition to green energy. But also, in my opinion, we have to also consider for this transition, the organic waste, because it should be used as a fuel of biological reactors to produce energy in form of biogas or hydrogen. So probably the use of biomass and waste is not the total solution, but it should be part of the final solution of energy issues we have nowadays.
Great. And lastly, let's hear from Juan.
Differentiate what is biomass from forest industry, from the forest, that of course we can produce energy from that. In our case, we would like to concentrate in the biomass coming from the wastewater plant. We are talking of the sludge, or also from the from other ways, like from pig slurry, or in the field of Horeca, hotels, restaurant and catering, all the organic waste. And in cities, what we are talking of the management of the urban solid, of the waste. So we have to separate that waste. And if I may, some figures. In 2018, 24% of the all municipal waste generated in the European Union was landfill. Okay, we have a challenge in that, is how to prevent the contamination in groundwater, and how to produce methane for other purpose, like swimming pools, like industry, or even for electrical mobility.
Great. Thank you so much, Juan. We love figures. Please keep sharing them. Carlos, Harman, and Juan, you all represent quite different parts of the bioenergy sector, which is something I love about this panel, from bigger industry to smaller SME, national to local, fast-growing crops to organic waste. You're really kind of representative of the full spread of the solutions that we're trying to apply within the sector to get to a really sustainable bioenergy transition. What I would just love for each one of you to take a moment or two to really kind of share what spoke of the bioenergy sector you represent, what element of it, and what sustainable solution are you advocating for and working to really bring into the market? Carlos, maybe we can start with you.
Perfect. In my case, I'm not from any spot of the energy sector. It's something strange. I'm working for a water utility called Global Omnium, but we are working in all parts of the water sector, and one part is the wastewater treatment plant. So in this water treatment, or the treatment of the wastewater, we have waste that this is sludge. And this sludge, depending on the size of the facility, we can introduce it into a digester, and we can produce energy at time we are stabilization the sludge to be used in agriculture or other use. So in this context, we are working to produce more and more biogas with our facilities, and also not only to produce a big amount, we will have to produce on demand. So we have not to flare the extra biogas production and or storage a big number of big quantity of this. This is the reason we have create or start a live project called co-digestion 2.0. So and this project is or the final objective of this project is to create a tool in order to control digestion and co-digestion inside of these digesters. Co-digestion is to introduce another waste apart from sludge into this digester to produce more energy. So with the application of this technology, we start to be a part of this energy sector, because we produce energy for self-consuming, or to put it into the grid.
Great. I love what you're doing and the role that a waste utility can really play in local bioenergy solutions. Harman, would you like to go next and tell us about the association?
Sure. Thank you. Much to what Juan's are saying is we are representing basically the biogas or biomethane sector within Europe. So this is biogas coming from wastewaters or municipal solid waste or from agriculture or from industrial waste. The biogas is being produced is often being converted either to electricity and heat or to biomethane being injected into the grid, or they make even bioenergy from it. Just to give you some numbers, as you love it, around about 30 to 40% we expect that we can supply of the future gas need in 2050. At this moment, we produce already enough energy as the whole country, Belgium, consumes on gas. And the beauty, I think, of biogas is that it's a full circular approach. You can really take your waste, make the energy out of it, but if the waste is proper and clean, you can bring back the waste back to the country, re-fertilize the soil. And if you do this rightly, and I will tell a little bit later about the concept as well, you can even combine it with carbon farming into the soil as well.
That's great. Thank you, Harman, and really looking forward to talk more about carbon farming with you. Juan, would you like to tell us about Finova in the area of the bioenergy sector you represent?
What is the Iceland for energy, renewable energy, and world example, the capital of the champions. What we do from our team are working from 25 years ago in the European Union arena, and we are managing for the European Commission DG Connect the Open Innovation Methodology Startup Europe Awards. One of our priorities is bioeconomy. That means in these difficult times after pandemic, where is an important crisis, what we are helping is to understand the access to EU funding. We are talking of 750,000 million euros next generation that combined with programs as LIFE or Interreg can help us turning this bioeconomy into reality. We have 10 years for doing that. And we have been working with these examples as live eco-digestion. It means we transform, we use one of that 18,000 depuration water treatment plants to digest the sludge, but also other organic waste, like pig slurry or waste from the HoReCa sector.
Great. Thank you so much. And Juan, I think your team might be unmuting yourself a couple seconds after you start speaking. We seem to be missing a few precious intro minutes from you just to go forward with. Great. Okay. Well, my next question, an important, and Harman, maybe we can start with you on this, but really keen to hear also Juan and Carlos's perspective afterwards. But an important consideration really for us to discuss here is how we can sustainably scale biogas. And you were speaking about all of these potentials to really meet a pretty large proportion of our biogas needs in a sustainable way with also carbon-based farming. So my question would be, can the sustainable feedstocks be scaled enough to meet our EU energy needs, especially for biogas, without competing with key things like food security or land use and biodiversity? And a quick follow-on to that, Harman, is not only is it possible and how, but given that we're in the digital space of the EU pavilion, how could the Commission be helping organizations and associations like yours to really ensure that even more? Are there key subsidies or regulations or additional data that they could be providing you to help you on this journey? We'll start with you, Harman.
Well, that is quite a few questions in one. I'll try to answer that. First of all, the simple answer is there enough biomass? Yes, there is enough biomass, sustainable biomass available. Be it, of course, that biomass is not in silver bullet on its own. So we need all solutions together to make sure that we quickly decarbonize. Now, one of the items which is important, I think biomass can actually answer a lot of the problems we currently have. And one of the problems we have is the fertility of our soil. So on how to tackle that is a new concept which is coming into place, which is a combination of carbon farming and energy at the same time. And if you allow me just a very brief overview on how that looks like, is that the farmers have their food and feed crop. So we must make sure we not are competing with food and feed, no land displacement. However, after your main food and feed crop, the land normally is bare. Sometimes they put in grasses with long rootings to do some kind of carbon farming. The problem with that is that after that, they have to plow in those grasses into the land, which is causing nitrogen oxide, N2O emissions, which again is a greenhouse gas, which you need to avoid. So what has been developed is the sequential cropping process. Basically, after your main crop, you put another crop on, which long rooting, allowing for carbon into the soil, and then you take off with minimum tillage without disturbing the soil, which is very important. You take off the crop which is left over in this period of time, which can grow, and you bring that to the digester. There you make your renewable energy. Important to know as well is if you make your biogas, the CO2 can be liquefied, which is biogenic CO2, and that should have within Europe a place in top of the capex, meaning that biogenic CO2 should be used in preference to any other form of CO2. Then, of course, the methane can be used, and the digestate can be brought back to the land to organically fertilize the soil. And also important to know is if you do that, actually, you increase the soil biodiversity, increasing the molds, increasing the structure of the soil, and actually also enabling the soil to capture the water more.
Great. Thanks so much, Harman. And within the work that you're doing in piloting this kind of process, what sort of biomass are you using in those kind of rotational crop farming practices? And also maybe can you tell me where in Europe do you think it's particularly beneficial to do this work?
Right. We researched, actually the University of Ghent researched that, and they looked at all climate areas of Europe, because this process is a little bit known already under the Biogas Done Right concept in Italy. And we said, okay, let's see what kind of crops we can grow in the various climate regions within Europe. And actually, this is a variety of crops, which is also an advantage because the crops is not one single crop. We actually can make a mix of crops. We can even put in flowers to cater for the biodiversity above the soil. And so per climate region, you can select your crop which can be used. Basically, biogas can use many kinds of crops, isn't it? So good to know for that is when you calculate the total potential of this system with only 15% of the arable land to be used, you arrive at an amazing number of around about 156 million ton oil equivalent, MTOE, so 185 BCM. That is already, and we are saying we only will use there probably 25% of that. So already an amazing number.
Great, an amazing number indeed. Juan, any additional points you might like to add on how we can really sustainably grow biogas within the EU bioenergy transition?
I think it's quite important, all the legislation from the European Union that are promoting that renewable energy, not only in Europe, but also in all over the world. Let's think in initiatives like TAIEX program or TAIEF program, technical assistance that are helping in Africa or Latin America or in other neighbors countries. Or for example, let's think in about programs like Euroclima. Then what we have is a wonderful legal framework that are inspiring third countries. Second, there are that funding available not only into Europe, but also in other countries. And biogas can come in an example here in El Hierro. They are really good in hydroelectric and they are starting with photovoltaic. Why not to transform the organic waste into biogas to reduce the energy from fossil sector? And we think that there is a lot of space to work in the agri-food sector in Africa. It's because of that the European Union promotes every year the Smart Agri-Food Summit that is in Malaga, is for 4 years. I think, and that's exchange information. We are now, and thanks COP26, we can exchange concrete ideas to implement and to transform the bioeconomy into reality.
Great, thanks. And Harman, one slight follow-up question for you from the crowd of our participants, and I think it's because you used a really interesting sounding word, biogenic CO2. Of course, the CO2 coming from the use of biomass. With your association, are you working on how CO2 emissions from biomass, how that's being accounted for within the EU current policy? Do you feel like it's being accounted and measured effectively? Any thoughts on how that relates to the current EU policy?
Excellent question. Actually, this is almost our daily work where we are busy with the biogenic CO2. Well, no, let's answer that first differently. If you look at the GRC and the studies they have done, they acknowledge that over the total life cycle of well, biomass, but also biogas, that the total life cycle is actually negative, meaning we are taking out CO2 out of the atmosphere in the process. Although, of course, in the burning process, either being it as a fuel, there is biogenic CO2 emissions. Now, this can be enlarged, of course, if we capture a large part of this biogenic CO2. What we see that within the transport, this is not being acknowledged at all. So there is no opinion of the European Commission to change that. But it is a great advantage if we would be able to use biofuels like biogas within the transport. If you look towards the maritime, there is a slight change already happening. They are looking more to the life cycle of the total. And if you look towards the ETS, so the trading systems, they are, and some of the areas, not all of them, but are saying biogas as a zero emission. That is already a good step, but we can be negative. So we would like to make sure that that's being accounted for in future as well.
Great, great. Carlos, let's bring you in a little bit here into the discussion. I'm really keen to hear your thoughts on what kind of realistic role possible unavoidable waste streams could be playing within the EU energy transition, and what scaling challenges you may be managing to mitigate either through innovative alignment of co-digestion of different waste feedstocks or different types of bioenergy production plants that are nearby local communities. Would love to hear more about your work in the local context.
Well, first I would like to start with our local experience because we started our project in a local waste treatment plant located in Spain, in the East Coast, in Valencia. It's called Cuarbenache. And here we have one process that consumes a lot of energy, that is the thermal drying, and this is not a linear consumption. We have also a peak of consumption when we switch on this system. And the idea of the project is to try to satisfy the energy demand of this process and also the rest of the plant during the peak and also during the linear energy demand. So in that way, we reduce the cost of treating wastewater, and at the same time, we reduce also greenhouse gases emission because we are not using energy from fossil fuels. Nowadays, we are applying our technology in this plant, but in a in a manual way, because now we are in this new project, we are trying to do it automatically, and we introduce inside of the digesters sludge and agri-food waste as co-substrate. We are not introducing in a linear way, we are introducing depending on the energy needs. So in this moment, we are covering this energy demand of the waste treatment plant. But this is not a local solution, because the idea is to implement this technology in other waste treatment plants or in other digesters outside of waste treatment plants. In this way, we have a lot of opportunity to scale up this technology. Specifically, we have about 3,000 waste treatment plants with digesters that treat sludge. So we, in our numbers, we have calculated that more or less we can produce 3 million megawatts per hour per year using our technology as increment of the current situation. And also we can treat about 1 billion tons of pig manure. I'm talking about pig manure because this is another co-substrate we are working with in our project. About the barriers to implement this technology, we have some barriers. One is legal barrier, because we have some legal barriers that we are not allowed to use some co-substrate inside of the digesters in waste treatment plants. We need to implement other technologies to use them. And also we have a limitation of quantity of this co-substrate we can use. We are limited about 75 cubic meters per day. So we can put it, we are not able to put it whatever we want. Also, we have market limitations in some places. Not in our case, because we are working with local companies that we are treating their waste. I'm talking about less than 100 kilometers from our facility, but we have in other places they are competing for this co-substrate because they have a value in the market, so they have to pay. Once you have to pay for a co-substrate, you go into the market, and the people or the company that pays more has this co-substrate. And another barrier could be the problem with the transport of these co-substrates, because sometimes companies they are worried about the cost of these transports. So maybe a solution of this barrier is to try to co-finance or doing like a public management that reduce cost of this transport and try to do it easily.
Great. And Carlos, the figure of 3,000 wastewater treatment plants in Europe, that's a big number. And the ability to really power themselves using the waste that they're collecting is really promising. Do you have a sense of how many of these actually could be using the solution that you're trialing, and what amount of energy is that within the EU?
Well, this is a good question, because there is no good data of this. This is a lack. Also, is this another barrier? Because to find out this number, we have to investigate or to research a lot, and we have this number is about 3,000 waste treatment plants. Nowadays, this co-digestion is used mainly in Austria. They are using a lot of this methodology, also in Germany and in some other places. But the use of tools to control this co-digestion, just to produce more and more biogas, maintaining the stabilization of the digester, this is not spread in Europe. And nowadays, they need to treat a waste, and then they are put it inside of the digester, but sometimes they do it manually, and sometimes they have problems. So the idea of use this tool is try to solve these problems and introduce co-substrates in a good manner inside of the digester, just to avoid the destabilization, because this causes a drastic reduction of methane. That is the gas we would like to obtain, just to burn it or use it in other things. So the number we have found or that we have is this 3 million megawatts per hour per year of increment, because we are taking the number of the current situation we have in Europe, and then putting the results we have obtained in our previous project. So it's more or less we will have an increment of biogas production between 10 and 14% of the current situation without using this kind of control.
Amazing. What was that total number, Carlos? You cut out for me for a moment.
The increase is 3 million megawatts per hour per year.
Incredible. Harman and Juan, we've heard some really interesting barriers from Carlos just now, including things like logistics and regulation. Juan, I'm also keen to hear what key barriers you feel that are really blockading kind of the evolution of a sustainable bioenergy sector at scale within the EU. And given Fenova's expertise in finance, I may ask you to start with the financial barriers.
Okay, let's start with that financial barrier. It's true that we have the technologies, the solutions from technological institutes, universities, or corporates as Global Omnium. But it's true that municipalities, provinces, cabildos, and regional governments, they need funding. And then for that funding, we have also a lack of capacity building in how to write good proposal in these times of submitting that projects. To be precise, allow me to explain that if you are listening to us, we have time enough to submit real projects before 30 November under the program LIFE, sub-program LIFE Circular Economy. An example is the project that Carlos has explained. We are talking of pilot projects of around 2 million euros, 60% subsidy. And what is more important, we can combine that public subsidies with other EU funding, like structural funds, Next Generation, or Horizon. And we could arrive up to, depending on the area, we could arrive 80, 95% here in Canary Islands, where we are today. Second, we have, and it's very important, the Horizon Europe funding, and concretely we have the program Innovation Fund. It means pilot projects, demonstrative pilot projects in the field of energy generation, energy efficiency, but also in stoking energy. We are talking of projects up to 15 million euros, 15 million euros. It's a lot of money, but it has to be an innovative and disruptive program. What we have to understand is that, again, we can combine that 60% of subsidy with other funding. And in our opinion, now with this Next Generation strategy from European Commission, we have a challenge. How to write a lot of quality projects that has to be approved and expanded before 2016. We have not a lot of time. Then what we do is we try to promote as maximum of small next generation projects, live projects up to 2 million euros, Horizon Europe projects. Why? Because once you receive the approval, we can scale. Then the example of a co-digestion project. Imagine how nice project. We are using that digesters to transform organic waste, pig slurry, from Horeca sector, from other organic waste into biogas. If we think there are 18,000 depuration water treatment plants, why not to use, and we solve different problems like the waste that are going today into the landfill. Then imagine that we bring the live eco-digestion project, and it doesn't mind in which region in Europe, or for example, in Canary Islands. What we could do is a next generation project based in live eco-digestion for all the depuration water treatment plants, helping the hotel, restaurant, and catering sector, Horeca sector, tourist sector has suffered a lot, reducing their cost of waste management, obtaining the biogas that Canary Islands, and as an example, requires and needs for their operation, and then we reduce the import of energy. And I'm ending explaining, we have a lot of administrative and legal barriers that comes from the interest of big energy companies that, of course, they are not very happy, most of them, that we start to obtain other energy, and also some companies in the field of waste management. Again, European Commission offered this live program and some legislation to fight against legal barriers that today don't allow us to turning the bioeconomy into reality. We need that to remove that legal barriers. Thank you.
And Harman, we've heard logistical, legal, regulatory barriers, the difficulty to apply for financial support, which I think we can probably all empathize a little bit with. Harman, I'd love to hear what barriers you see from the association's perspective, particularly on biogas.
And there are quite a few, and I think Juan already mentioned some, but let me try to summarize. I think what is failing is that a lot of the barriers are politically based, and we need to go to science-based targets. So we need to make sure that we are putting science up front, which proves, if we want to move fast, proves which techniques can be used. And for that, we should make sure that, for example, in the Renewable Energy Directive, there is no capacity cap on biomass or sustainable biomass to be used. There is now a cap in there. We need as broad as possible to make sure that it's in there. We also need to make sure that there are targets being set for example, renewable gas to be used and biogas and renewable gas to be used, to make sure that things are moving faster than we do right now. Also, with regard to taxonomy, which is also a big thing within Europe, the taxonomy is seems to be a political instrument. So they are far away from the science-based targets and trying to promote, say, not a level playing field, but promoting electricity only. So we need to make sure that those barriers are being lifted. And of course, I can talk about a tax directive and an alternative fuel infrastructure and all that. But those are, I think, the main ones. Science-based targets make sure that we are leading into the next era.
Great. Thanks, Harman. And I actually have a follow-up question for you from someone in the audience, really diving into syngas. In particular, how might biogas from processes like wastewater treatment plants, like Carlos is working in, how do those compare with syngas that's coming from the thermal treatment of urban mixed waste? Harman, and then also Carlos, if you want to jump in, please feel free.
Okay. Let me first say that the gasification of syngas is a process which is in parallel to the biogas sector. So there are streams which the biogas sector cannot treat because they are high lignin or they are different. And gasification offers a solution, especially the second generation gasification, which is in there, and the syngas coming from it. So what we can think of is in those 18,000 wastewater treatment plants we have in Europe, we can first of all anaerobically treat the wastewater, after which the sludge can even be going into a gasification plant because the sludge often is being polluted and we cannot use it as organic fertilizer. So I see it really as an addition. And when we see, I said before, we can reach around about 30 to 40% of the total gas usage in future within Europe. Around about 30% of that will be coming from syngas gasification type technology.
Great, thanks, Harman. And Carlos, would you like to add anything there?
I think Harman explained perfectly about this technology.
Great. Great. Okay, well, both last question from me, and then as well, anyone from the audience, if you have any burning questions, please make sure to pop them in now so we can get them included before our close at 9:30. But Carlos, Harman, and Juan, my last question is to ask you all for a final closing statement. Our event is, albeit digital, part of the EU Pavilion, which has a footprint inside the Blue Zone, where all of our European leaders are busy this week and next with our oncoming negotiations, and energy is going to be a huge part of that. In regards to really ensuring a just, viable, and scalable bioenergy sector for Europe that is truly sustainable, what would be your main message that you want to share with these policymakers? What should they be going into next week carrying in tow? Harman, can we start with you?
Big question. But I would say, and of course, with regard to biogas, we can be a multiple solution, not only on the energy side, which is already being talked about a lot. So let's say for the politicians, 3 words to remember. It is available, it is sustainable, and it is scalable right now. So do not wait.
Great. And Carlos?
Yeah, just to add to the final statement of Harman, I would like to say that both in academia and industry are developing nowadays technologies using waste just to satisfy energy demand, probably not all the energy demand of the continent, but part of it, with green energy, so renewable energy. But we need more support for its implementation in both economic and also regulations.
Thanks so much, Carlos. I agree. Juan, over to you for the final closing statement.
Okay. The statement is, please try to follow the different debates that are tomorrow. For example, there is an important event in the island of La Palma that is in COP26, is about the circular and disruptive solutions in textile fashion. That is quite important. And next Monday at 6:30 we will be in Glasgow about all the challenge of the biomass from the forest, firefighting. And again, and the clear message, we need to work together. We need public-private partnership alliance. That means politicians, municipalities, industries, enterprise association, to promote innovation in how we manage the waste, and from the waste we can obtain energy, as we have seen, but also we can obtain new materials, raw materials. We can obtain new materials to do things. That is and for that we are offering all of you to work under the European Commission methodology Startup Europe Awards, defining a challenge, identifying the startup or the university, and after, with funding from the European Union, implementing not only for European Union entities, also we have done that in Mexico, in Chile, and Panama, and the planet needs the effort from all of us.
Perfect clothing statement. The planet needs effort from all of us. I very much agree. Thank you all so much, Carlos, Juan, Harman, for a great conversation. I hope you enjoyed it as much as I did. And thank you everyone from tuning in virtually, wherever you are, whether you're with us here in Glasgow or farther afield. And last thank you to the European Commission.
Excuse me, Liz.
For
Excuse me,
hosting
Liz.
us.
Excuse me, Liz. Remember, we have to do the award of the Startup Europe Awards. It's 1 minute, yes. We are going now to announce the winner of the special edition Startup Europe Awards in bioeconomy, and the winner is a Malagan company, a startup from Malaga, Mr. Rafael Cintora, and is Tex Factory. Tex Factory is a startup that brings natural raw materials and formulate new construction materials, and they are working in recovery marine, vegetable, and mineral waste to use for recycling. And allow me to end just the president of the island of El Hierro is here to offer the island as a living lab for energy. In 1 minute.
Okay, yes, if I have a minute, Juan, thank you. Thank you all. First thing is say hello to people attending to the First Oceans International Congress of El Hierro Biosphere Reserve and the World Biological Corridor. Second, to greet you all, to thank you for allowing us to be with you in one way or the other in this COP26. We want to say that from this last southwestern spot of Europe, that we are committed with the renewables, we are committed with fight against climate change and greenhouse effect. We try to translate into facts. Into facts? We have the 60% of our territory protected. We are a biosphere reserve from 2000. We are green pack. Geopark from 2015, and we produce with the hydro wind power station the 60%, as I said, of the electricity of the island. Not biomass, but everything will go. We'll try to have. We are not happy with this 60%. Our aim is to produce the 100% of the electricity of the island. Anyhow, we proposed the target of 30% that you say for the 2030. Facts and no proposal. I want to say you that El Hierro is a lab, and we are really ready to embrace and we will be very happy to embrace any European project on renewables. El Hierro is a place, El Hierro is where things will happen in the renewables fields. Thanks a lot, and we'll be happy to hear from you.
Great, thank you so much both for the unexpected addition. Carlos, Harman, and Juan, thank you so much for participating. And again, thank you to the European Commission for having us within the digital version of the pavilion. Enjoy the remainder of the COP, everyone.
Thank you, Liz.
Thanks, Liz.
Thank you all.
And you and Metabolic for the conversation.
Thanks, everybody.